Right. We can use technology to solve these questions. Most parts. Well, anyway, we'll start by doing the first part because it's pretty straightforward. The initial oil production, basically, what's the value of P when T is 0? And so we have half 2, 0 plus 15, and when it's e to the power 1 minus 0, we calculate this, you get 15 e to the power 1. I'll get the calculator. Okay, and so this is 0.5 times 15 times e to the power 1 right here. So it's approximately 20.3, or well, let's make it 20, approximately 20.4. That is barrel per year. It's a billion barrel. Alright, now the part 2 here, we find time when oil production rate is reaching its maximum. We know it's at this point we're talking about, so we want to find the corresponding time. And so you can do it algebraically, and I want to start a little bit on it. I'm going to differentiate this. Remember, this is actually half 2t plus 15. I can let this be u, and then it is let this 0.06t be v. So let this be u is v, and I can use a product rule, right? And so I get 2 du v du dx. I'm going to do that first. 1 minus 0.06t plus this, and this is a negative 0.06. Hey, and so we set dp/dt is 0 because we want to find a stationary point. In this case, a local maximum, and it's eliminated. And there's a common factor of this exponent. I can factorize this exponent 0.06t. This term here, you get 1. I get if you do the calculation carefully, you get negative 0.03, right? And 2t plus 15, and that's it. And we set this to 0, and so this term here, this expression here, the e to the power something, this it will never be 0. Exponential function never be 0, and so must be this expression is 0. You solve this. I'll leave the algebra to you. Then you get t be equal to 55 over 16, 6 actually, over 6, and that is approximately 9.16 or 17 years. Of course, this is we take as 9 years. So to nearest year, that means that in 2009, because the study begins in the year 2000, so 9 years, 2009, the production rate reach maximum, right? And when they ask you to find the total oil production from here, I'm going to do in this part and find some space for myself. And so they ask you to find from here the area under curve from here until 50, and so that means total production means from 0 to 50. You put in the function pt and pt and do this. I'm not going to do this, but I'm going to use the GC to help us. Say already graph. I've entered this function, okay, but I have yet to set up my viewing window. I'm going to set the time or the x-axis, that means the horizontal one, from 0 to say 55. It should be 50, but 55 is just nice. And production rate wouldn't be 0, as you can see. I'll take a guess. I try to well, put 50, right? 50 billion barrels. I'll grab it. Okay, just nice. I got what I need. And so I want to solve this. Find the area from 0, low bound, and 50. And from technology, I get the answer to be roughly 928. Okay, so it's roughly 928 billion barrel. Okay, and so move on to the next part here. Okay, now only consumption rate is given by this function. Alright, now before we start, I think we probably can enter the function into here, because it asks you to sketch. You notice this. So we're gonna enter this 12 power e and 0.02 t. Right, I'm gonna try see how it goes. Okay, just nice. This is so the setup of the view windows is nice. And so sketch the graph of oil consumption rate on the same set and have a look again. Make sure you transfer the information from here to here. That's actually a meeting point, intersection point. We can find this first, more or less can intersect it. Alright, so when time is roughly 24 years plus, so somewhere in between 0, about roughly 25. So I just make sure I 25 is about here. So this is the point where you meet, and you would go something like this. Oh, go something like this. Okay. And so they ask you to find. So this is this point here is roughly, you should label it correctly, 24.9. And because you can use technology to graph it, so there's no excuse that you can't label this 24.9. There's this you could do, and here even actually you can find it, because when t is 0, this is 1. E to power 0 is 1. So C0 we know is 12. So this should be labeled so 12. Okay, and lastly, to find this and interpret your answer. And so means we being asked to find this 50 of production minus consumption. Remember, CT is consumption, DT, and 50. We have calculated this as roughly 228. And to do this part, we use a calculator again. So just solve it. This I'm going to deal with this. Okay, check this. And so, alright, 0 to 50. So it's 1030 point, about 1031. So it's roughly 1031, and the answer is negative 103 billion barrel. Oh, this is a problem, isn't it? And so interpret the answer. And so from 2000 to 2050. There will be a shortage. This is a problem, isn't it? So we keep using oil without thinking the consequence. Will be We still need another 103 billion barrels. So that's the interpretation of the answer, and I hope you try and do other questions, and good luck.